Welcome in. Come and find your place for this moment. Let the weight of your body settle into the surface that holds you. There is nothing else you need to be doing. Nowhere else you need to be. Just here. Feel the quiet architecture of the room around you, the gentle pressure of the air on your skin. Listen to the soft, rhythmic sound of your own breathing, a constant, effortless anchor in the present. This is a space for curiosity to unfold at its own pace, a space where questions can be held without the immediate need for an answer. Tonight, we are not here to conquer a topic, but to simply accompany it for a while, to walk alongside an idea and see where it leads without hurry. The world outside can wait. The lists and the pressures can fade into the background. For now, there is only the stillness of this moment, the darkness behind your eyes, and a single, gentle question that we can explore together. It's a question that connects the warmth of the room you are in right now to a world of unimaginable cold. It links the soft fabric against your skin to hides scraped clean by flint. It bridges the effortless flick of a light switch to the patient tending of a fragile flame. The question is not about strength or dominance or some grand tale of heroism. It is quieter, more intimate than that. It's a question of texture, of knowledge, of belonging. What if the boundary between your world and a world of ice, a world that seems impossibly remote and harsh, is more porous than you imagine? What would it truly mean, not just to endure, but to belong to a time when glaciers stood miles high and the wind carried the scent of pine and mammoth? How could you, the person you are right now, with the mind you possess and the hands you have, find a way to live, to understand, and perhaps even to thrive in the Ice Age? Let's begin there. Tonight, we are going to build a model together, not a definitive final answer, but a provisional sketch, a way of thinking about a world that is both utterly alien and profoundly foundational to our own. Our central question, how you could survive in the Ice Age, is not a test. It is a lens. It is a tool for inquiry. Our method will be one of careful assembly, piece by piece, starting with the familiar and moving slowly toward the strange. We are not aiming for certainty, because certainty about a world 20,000 years gone is a fragile thing. Instead, we are aiming for a richer, more nuanced understanding. We'll look at the evidence, of course, the fragments of bone, the whispers in the ice cores, the silent testimony of stone tools. But we will treat them not as facts to be collected, but as clues to be interpreted. An interpretation is always a creative act, one that depends on the questions we ask. Our approach will be to hold multiple possibilities at once. We will explore the conventional narratives of a brutal, desperate struggle for existence, and we will also make space for alternative interpretations that suggest resilience, deep knowledge, and a profound connection to the landscape. The guardrails for our exploration are simple. First, we will favor inquiry over dogma. When we encounter a gap in the record, we won't rush to fill it with speculation. We will simply note the empty space and acknowledge the limits of what can be known. We will ask, what does this absence tell us? Second, we will move between scales, from the microscopic details of a carved piece of antler to the planet-wide shifts in climate and ocean currents. The story of survival is written at every level, from the way a person held a tool to the way the Earth tilted on its axis. Third, and perhaps most importantly, our guiding principle will be a kind of intellectual humility. We are visitors to this past, and we must tread lightly. We will avoid imposing modern values or assumptions on people who lived in a fundamentally different reality. We are not here to judge their lives, but to try, as best we can, to imagine them. This is not a documentary of settled facts. Think of it more as a guided meditation on deep time, a speculative journey grounded in evidence. We are building a framework, a mental toolkit, that allows us to ask better questions. The goal is not to arrive at a single, triumphant conclusion, but to leave with a deeper appreciation for the complexity of the past, the resilience of life, and the enduring connection we share with those who walked this earth long before us. So as we begin, let go of the need for a simple story. Let's embrace the ambiguity, the mystery, and the wonder of it all. We are simply here to ask, to imagine, and to learn together. So let's begin where you are, right now, in this room. Take a moment to feel the temperature of the air. Notice where it feels cool on your skin, perhaps on your face or hands, and where it feels warm, perhaps under a blanket. This simple sensation, temperature, is the primary reality of the world we are about to explore. But for you now, it is a managed reality. A thermostat somewhere, a window closed against the night, layers of fabric. These are all technologies of comfort, so seamlessly integrated into our lives that we barely notice them. But just for a moment, notice them. Feel the specific texture of the material closest to your body. Is it cotton? Wool? A synthetic blend? Its softness, its weight, its ability to hold or release heat. This is the immediate boundary between you and the world. Now, expand your awareness to the room itself. What are the materials that surround you? Plaster walls, wood, glass. Each of these materials is a shield, a membrane that separates the controlled climate of your immediate space from the uncontrolled world outside. You can likely hear the faint sounds of that world, the whisper of wind, the distant hum of a car, the creak of a house settling. These sounds are filtered, muted. You are inside, looking out. This feeling of being inside is one of the fundamental experiences of modern human life. We spend so much of our time within these carefully constructed envelopes of conditioned air and filtered light. Now let's perform a simple act of imagination without changing anything, just by shifting your attention. Feel the floor or the foundation beneath you. Below that is the earth, soil, rock, clay. It is there, just a few feet away, holding you up. It is a direct physical connection to the planet, a connection we often forget. Feel its solidity, its stillness. The weather, which might be a distant thought or a glance at a screen, is happening right now just on the other side of that glass and plaster. Rain might be falling, the wind might be blowing, the temperature is what it is, dictated by the season, the time of day, the movement of vast systems of air and water. You are insulated from it, but you are not separate from it. This simple sensory inventory of your body, your clothing, your room, the ground beneath, the weather outside, is our starting point. It is our orientation, because to understand what it meant to live in the Ice Age, we must first understand what it means to live now. In this precise moment, in this specific place, we have to become aware of the invisible layers of technology and infrastructure that mediate our relationship with the planet. Before we speak of glaciers and megafauna, we must first become grounded in the present tense, in the undeniable reality of our own embodied experience. This is our baseline. This is the world from which we are departing. Why does this question of survival in a world of ice truly matter? It can feel like a distant academic puzzle, an interesting thought experiment for a quiet night, but ultimately disconnected from the realities of our own time. But the stakes, I think, are higher than that. They operate on two very different timescales, the human and the geologic, and it is at their intersection that the question finds its relevance. On the human scale, the question is about resilience. It's about understanding the baseline capacities of our species. We live in a world of profound technological dependence. Our food, our water, our shelter, our knowledge, all are delivered through complex, interconnected systems that are, for the most part, invisible to us. And because they are invisible, they can feel both permanent and fragile. Exploring the lives of Pleistocene people is a way of peeling back those layers of abstraction. It reminds us that for over 95% of the time Homo sapiens have existed, we lived in a radically different way. We survived not through overwhelming force, but through intimate knowledge, adaptability, and social cooperation. The skills they possessed, reading a landscape, understanding animal behavior, crafting tools from the raw materials of the earth, were not hobbies. They were the very grammar of existence. To contemplate their world is to reacquaint ourselves with a part of our own heritage, a set of cognitive and physical abilities that may be dormant but are not necessarily lost. It's a powerful reminder that our current mode of living is a very recent experiment, not an inevitability. On the geologic timescale, the stakes are about perspective. The Ice Age was not a simple, static period of cold. It was a time of immense climatic volatility. Temperatures could swing dramatically, sometimes within the span of a single human lifetime. Sea levels rose and fell by hundreds of feet. Entire ecosystems appeared and vanished. The world our ancestors inhabited was one of constant, radical change. They were, by necessity, masters of adaptation. To study their world is to study a planet in flux, a planet operating under a different set of rules. It gives us a visceral sense of how dynamic the Earth's systems can be. It moves climate change from an abstract concept represented by graphs and charts to a lived reality. These were not future projections, they were the present tense for tens of thousands of years. It helps us see that stability is the exception, not the rule, in Earth's history. And it shows us a species, our own, that successfully navigated that instability for millennia. So the question is not just a fantasy of rugged individualism. It is a tool for recalibrating our sense of time, our understanding of change, and our definition of what it means to be human. It matters because it connects us to the deepest parts of our own story and to the profound, ever-changing story of the planet itself. It quietly suggests that the wisdom needed for the future may have roots in the deepest past. As we move forward, a few threads will begin to emerge. Think of them not as plot points in a story, but as recurring patterns of inquiry that we will revisit from different angles. We don't need to resolve them now, we just need to become aware of them, to plant them like seeds in the back of our minds. The first thread is the idea of knowledge versus information. In our world, we are surrounded by information, vast external libraries of data that we can access at any time. But how much of that information translates into embodied knowledge, into a skill that lives in your hands and your senses? We will explore how Ice Age people carried their encyclopedias in their minds, in their stories, and in their social groups. The survival guide wasn't written down, it was lived. The second thread is the tension between hardware and software. Our biological hardware, our bodies and brains, is largely the same as that of a person living 20,000 years ago. The changes are, in evolutionary terms, minor. The difference is the cultural software we are running. We will keep returning to this idea that the key to their survival wasn't a different kind of brain, but a different way of using that same brain, a different set of operating principles for perceiving and interacting with the world. And a third thread to watch for is the relationship between scale and perception. We will see how survival depended on an incredible ability to shift scales of attention, from the subtle change in the texture of a flint nodule to the seasonal migration patterns of herds over hundreds of miles, to the generational understanding of how a landscape was changing over decades. This fluid awareness, this constant zooming in and out, may have been one of the most critical cognitive tools they possessed. So keep these ideas in the background as we proceed. Knowledge over information, hardware versus software, and the dance between different scales of time and space. We will return to them. For now, they are just signposts, marking paths we will explore more deeply later on. Before we go any further, it's useful to establish a few working definitions. These aren't rigid academic pronouncements, but simple, plain language agreements that will help us stay grounded. They are the assumptions we are building upon. First, when we say the Ice Age, what do we actually mean? The term is a bit of a misnomer. The Earth has experienced many ice ages. The one we are talking about tonight is the most recent glacial period of the current Ice Age, a time geologists call the Pleistocene epoch. Specifically, we'll be focusing on a period known as the Last Glacial Maximum, or LGM, which peaked around 20,000 to 26,000 years ago. This was a time when vast ice sheets, in some places 2 miles thick, covered much of North America, Europe, and Asia. It wasn't uniformly frozen. There were vast, unglaciated regions, but the world's climate was, on average, significantly colder and drier than it is today. So, for our purposes, the Ice Age refers to this specific, intensely cold and arid period. Second, who are the you in our question? Who are the people we are talking about? We are talking about Homo sapiens. Anatomically, modern humans, just like us. Their bodies were our bodies, their brains were our brains. They had the same potential for complex language, abstract thought, and symbolic culture. It's crucial to remember this. We are not talking about a different species. We are talking about our direct ancestors, equipped with the same biological toolkit. The differences were cultural, technological, and environmental, not biological. Third, what do we mean by survive? This is a key term to unpack. Let's move beyond the simple binary of living or dying. For our exploration, survival means more than just caloric intake and staying warm. It means successfully raising children to adulthood. It means transmitting knowledge across generations. It means maintaining social cohesion in small mobile groups. It means creating art, music, and ritual. In short, survival means living a complete human life, not just enduring a biological process. It implies resilience, continuity, and culture. Finally, a note on our primary assumption. We will assume that these people were not primitive or simple. We will assume they were intelligent, observant, and highly skilled experts in their own world. Their technology was different based on stone, bone, wood, and fiber, but it was not unsophisticated. It was elegant, efficient, and perfectly adapted to their needs. We are starting from a position of respect, assuming competence and complexity. These simple definitions, a specific time, a modern human, a rich definition of survival, and an assumption of competence, will serve as our compass. They will help keep our inquiry focused and prevent us from falling into common misconceptions about this deep and fascinating chapter of our own story. To understand their world, we need a brief, high-level snapshot of what it was like. Let's paint a picture, not with names and dates, but with broad environmental strokes. Imagine the planet's thermostat turned down by about 5 to 6 degrees Celsius on average. This may not sound like much, but the effects were dramatic. A huge amount of the Earth's water was locked up in those immense ice sheets. With so much water pulled from the oceans, sea levels were profoundly different, as much as 400 feet or 120 meters lower than they are today. This exposed vast areas of land that are now underwater. Britain was not an island. It was connected to mainland Europe by a vast, low-lying plain now called Doggerland. Siberia and Alaska were connected by a wide land bridge called Beringia. The geography of the world was fundamentally redrawn. The atmosphere was also different. It was much drier and dustier. The cold air could not hold as much moisture, and the powerful winds blowing off the glaciers picked up fine sediment, carrying it for thousands of miles. This dust, found in ice cores and deep-sea sediment, is one of the key fingerprints of the era. Vegetation was, as you'd expect, radically transformed. The forests we know today were compressed into smaller refuges closer to the equator. In their place, much of the unglaciated world was covered by a type of ecosystem that has no perfect modern analogue, the mammoth steppe. This was a vast, cold, dry grassland, stretching from Spain to Canada. It was not a barren tundra. It was a rich pasture, supporting an incredible density of large animals, the so-called megafauna. There were woolly mammoths, of course, but also woolly rhinos, giant Irish elk with antlers spanning 12 feet, steppe bison, horses, and formidable predators like cave lions, cave hyenas, and giant, short-faced bears. This was the world humans shared. They were not the apex predator in every context. They were one part of a complex and often dangerous food web. Their lives were intimately tied to the rhythms of these animals and these plants. The human population at this time was tiny. The best estimates suggest the entire global population of Homo sapiens was likely less than 1 million people, perhaps far fewer, scattered in small, mobile groups across Africa, Eurasia, Australia, and eventually the Americas. They were a rare species on a planet that was, in many ways, an alien world. This is our backdrop, a colder, drier, dustier planet with a different map, dominated by grasslands and giants. It is into this world that we must place ourselves. Let's begin our exploration at the human scale with the most direct evidence we have of individual lives and choices. Consider a single object, a stone tool. Not just any tool, but a specific type known as a Solutrean laurel leaf point, found in parts of France and Spain from around 22,000 years ago. These objects are breathtaking. They are long, thin, almost impossibly delicate blades of flint, shaped like a willow leaf. Some are over a foot long but less than half an inch thick. They are masterpieces of craftsmanship. Now let's follow our evidence track. Example, mechanism, implication. The example is the object itself. Its symmetry is perfect. The flaking pattern is so regular it seems almost machine-made. But this was achieved by hand, eye, and an intimate understanding of the material. The mechanism for creating such an object is called pressure flaking. After shaping the rough blade with percussion, striking it with another stone or a piece of antler, the final fine work was done by applying precise pressure with a pointed tool, likely the tip of an antler, to press off tiny, rippling flakes. This requires immense control, patience, and knowledge. The flint often had to be heat-treated beforehand, baked carefully to a specific temperature to make it more workable, a process akin to primitive pyrotechnology. The napper had to know the stone, to read its internal structure, to feel how it would break. This was a skill that would have taken a lifetime to master. Now, the implication. Here's where it gets interesting. Many of these laurel leaf points show no signs of use. They have no edge wear, no impact fractures. Some have been found in caches carefully buried together, and they are often made from the most beautiful, high-quality flint, sometimes transported from many miles away. This suggests they were not just utilitarian spear points. A simpler, thicker, more robust point would have been just as effective for hunting and far less costly to make. One mistake, one misplaced press of the antler, and weeks of work could shatter. So why make them? This is where we move from a simple tool to a complex cultural object. The sheer beauty and craftsmanship suggest they had a value beyond their function. Perhaps they were status symbols, a way of displaying incredible skill and mastery. Perhaps they were ceremonial objects used in rituals. Perhaps they were a form of social currency, traded between groups to cement alliances. The energy and risk invested in their creation implies a society that had enough stability and resources to support this kind of specialized, non-essential production. People were not living in a constant, hand-to-mouth state of desperation. They had time for art. They had time for beauty. They had time for complexity. The simple stone tool, when examined closely, opens a window into a world of social relationships, aesthetic values, and symbolic thought. It tells us that survival was not just about calories, it was also about culture. And so we are left with a question. If this level of artistry and social complexity was possible, what other aspects of their lives, the parts that don't preserve in the archaeological record, might have been equally rich and sophisticated? What happens when we test the boundaries of this implication? If the existence of highly crafted objects like laurel leaf points suggests a level of social and economic stability, what are the edge cases? What evidence might challenge or complicate this picture? Let's consider the context in which these tools are found. The Solutrean period, when these points were made, corresponds with a particularly cold and harsh phase of the last glacial maximum in Europe. These people were living in close proximity to the ice sheets in what would have been a very challenging environment. It's possible that the very harshness of the conditions spurred this kind of technological and artistic flourishing. Perhaps in a time of scarcity and risk, demonstrating skill and reliability became even more important. A hunter who could produce such a point was demonstrating not just craft, but patience, foresight, and access to the best materials, all qualities you would want in an ally or a mate. In this view, the art isn't a luxury of abundance, but a critical social signal in a time of stress. Another edge case is the distribution of these objects. They are found in a specific region for a specific period of a few thousand years, and then they disappear, replaced by a different, more practical toolkit. This suggests that this cultural expression, this focus on extreme craftsmanship, was not a universal human trait of the era, but a localized phenomenon. It was a particular solution, a particular cultural fashion that arose and then faded. This reminds us not to overgeneralize. The Ice Age was immense in both time and space. Different groups of people in different parts of the world found different ways to live, to cope, and to create meaning. The Solutrean phenomenon in Western Europe is not necessarily representative of life in Siberia or Africa at the same time. Preserving this calm, methodical cadence, we must also acknowledge the role of preservation bias. Flint is durable. It survives for tens of thousands of years. Objects made of wood, fiber, hide, or sinew almost never do. We see the stone, so we build our stories around the stone, but what if the true artistry, the true complexity of their material culture was in the things that have vanished? The intricate weaving of a basket, the clever design of a snare, the detailed painting on a leather tunic. The stone points might be just a tiny, unrepresentative fraction of their creative output. The implication of stability and complexity holds, but these boundary tests add necessary nuance. It suggests a picture that is more dynamic, more localized, and more incomplete than we might first assume. It forces us to remain humble and to remember that we are always looking at the past through a keyhole, seeing only a sliver of the full picture. Now let's zoom out from the individual object to the larger systems that govern their world. Life is a network of feedback loops. Organisms don't just exist in an environment, they interact with it, shaping it and being shaped by it in a constant, dynamic dance. This is true at every scale, from the bacteria in our gut to the entire planetary climate. For Ice Age hunter-gatherers, a critical system was the relationship between predators and prey. Let's look at this not as a simple chase, but as a coupled system with built-in regulation. Consider the vast herds of migratory animals like reindeer, bison, or horse. Their populations were not static. In a good year with plentiful forage, their numbers would grow. As their numbers grew, they would provide a more abundant and reliable food source for their primary predators, not just humans, but also wolves, lions, and hyenas. The predator populations, with more food available, would in turn increase. This is a positive feedback loop. More prey leads to more predators. But then a negative feedback loop kicks in. As the predator population grows, they exert more pressure on the prey. They hunt more animals, culling the herds. With fewer prey animals to go around and perhaps increased competition, the predator population can no longer grow at the same rate. It might stabilize or even decline. This decline in predators then eases the pressure on the prey population, allowing it to recover and begin growing again. This is a classic predator-prey cycle. It's a natural thermostat, a form of homeostasis that regulates the populations of both species without any conscious intention or planning. It's a dance of numbers, playing out over years and decades across the mammoth steppe. Humans were a part of this system. They were one of the key predators. But unlike a wolf or a lion, they had culture. They had memory. They could observe these cycles. They would have understood that wiping out a herd in one season would lead to starvation in the next. This understanding would have likely been encoded in their cultural practices, in hunting rituals, in stories, in social rules about when and where to hunt and how much to take. Their survival depended on not breaking the regulatory feedback loop. They weren't conservationists in the modern sense. That's a teleological and anthropomorphic framing. They were simply participants in a system whose rules they had learned through thousands of years of observation. Their hunting strategies were likely designed to be sustainable not out of abstract principle, but out of direct, pragmatic necessity. The system itself, through its feedback mechanisms, rewarded behaviors that maintained its stability and punished those that did not. If we follow the logic of these feedback models, what are the second-order effects? What are the less obvious implications of living as an integrated part of a self-regulating system? One major implication is a different conception of time and planning. In a world governed by seasonal and multi-year cycles, planning is not about linear, long-term accumulation, as it might be in an agricultural society. You cannot hoard wealth in the same way. Your wealth is the health of the ecosystem around you. Planning becomes cyclical. It's about knowing where to be at what time of year to intercept the reindeer migration. It's about knowing which plants will be available after the spring melt. It's about understanding the multi-year boom and bust cycles of smaller game animals. Time is not a straight line moving towards progress. It is a spiral, a recurring pattern of seasons and events. Your memory, and the collective memory of your group, is a map of this cyclical time. Another implication is the nature of property and territory. For highly mobile groups following migratory herds, rigid, fixed territories make little sense. Instead, territories were likely fluid, defined by relationships and agreements between different groups. Your territory was not a patch of land you owned, but a set of rights and responsibilities related to the resources within a landscape. You might have the right to hunt in a certain valley during the autumn, while another group has the right to fish the river in the spring. These arrangements would be maintained through social connections, through trade, marriage, and shared rituals. The system's dynamics favor cooperation and information sharing over rigid exclusion. The health of the herd, which might travel 1,000 miles, depends on the behavior of many different human groups along its route. A breakdown in cooperation in one area could have cascading effects for everyone. Finally, this perspective changes our view of human agency. It moves away from a story of man versus nature and towards one of humans within a system. Their intelligence was not applied to conquer the system, but to understand its patterns and navigate them skillfully. Their agency was expressed through attunement and response, not domination. This is a subtle but profound shift. It suggests that their worldview, their entire way of being, might have been fundamentally different, less about imposing their will on the world and more about finding their place within its intricate, interconnected web. Sensitivity to the system's feedback, not raw power, was the key to long-term success. We've been on this journey for a little while now, moving from the familiar space of your room to the deep past. Let's just pause for a moment. Take a breath. Notice again where you are, the time of night, the quiet around you. It's easy to get lost in these large scales of time, so it's good to ground ourselves back in the present. As you're listening, people are tuning in from all over the world, in different time zones, in different seasons. Someone is listening as dawn breaks, someone else in the deep of the night. It's a quiet, invisible community of curiosity. If you feel inclined, you can leave a comment with just the city or country you're listening from and what time it is for you. It's a simple way to map the reach of our shared exploration. And if you are finding this journey restful and engaging, a gentle click of the like button or a subscription to the channel is always appreciated. It helps others who are seeking a quiet, thoughtful space like this to find it. But there is no pressure. The most important thing is that you are here. So let's settle back in. Let's allow the present moment to be our anchor as we prepare to dive back into the world of ice and stone. Now, it is essential that we give a fair and strong hearing to the more conventional explanation of life In the Ice Age, this is the steelman, the strongest possible version of the argument we must consider. This view, grounded in decades of archaeological and anthropological research, paints a picture of life that was, in the famous words of the philosopher Thomas Hobbes, nasty, brutish, and short. The evidence for this is compelling and cannot be dismissed. Let's examine it piece by piece. First, skeletal evidence. The remains of Pleistocene humans often show signs of severe physical stress. Harris lines, which are thin lines of increased bone density visible on X-rays, indicate periods of arrested growth in childhood due to malnutrition or disease. Dental enamel hyperplasia, which are defects in the tooth enamel, tell the same story of physiological stress during development. Arthritis was common even in relatively young adults, a testament to a life of hard physical labor. And traumatic injuries, broken bones, fractured skulls, are frequently observed, suggesting a life filled with risk, whether from hunting large, dangerous animals or from interpersonal conflict. Life expectancy was also brutally short. While some individuals certainly lived into their 40s or 50s, the average was likely much lower, skewed by extremely high rates of infant and child mortality. Surviving the first few years of life was perhaps the greatest challenge of all. This was not a world of gentle, peaceful aging. Second, there is the evidence of scarcity. While the mammoth steppe supported a large biomass of animals, these resources were not always available. Herds could fail to appear. A long, harsh winter could decimate local game populations. Plant foods, especially in the high latitudes, would have been scarce for much of the year. Chemical analysis of human bones, which can reveal diet, often shows a heavy reliance on a narrow range of food sources, typically large herbivores. A specialized diet is a risky diet. If your primary food source disappears, you have no fallback. This suggests a life lived on the edge of nutritional precarity. Third, the environmental conditions themselves were undeniably extreme. The cold was a constant threat, and the risk of hypothermia was ever present. Shelter and fire were not comforts, they were absolute necessities for survival. The vast, open landscapes offered little protection from the relentless winds. Simply moving through a snow-covered landscape in winter would have required an immense expenditure of calories. This view argues that any cultural or artistic achievements like the cave paintings or carved figurines should be seen as remarkable exceptions, flickers of light in an overwhelming darkness, rather than as evidence of a comfortable or stable existence. It posits a life defined by a constant grinding struggle against starvation, cold, and death. This is a powerful and well-supported interpretation, and it forms the necessary foundation for any further inquiry. Alongside that mainstream interpretation, let's place some alternative ways of reading the same evidence, presenting them neutrally, side by side. The goal here is not to declare one right and one wrong, but to see how different frameworks can lead to different conclusions, and to identify the unknowns that lie between them. Let's take the skeletal evidence. The high incidence of healed fractures can be read in two ways. On the one hand, it points to a life of frequent, violent trauma. On the other hand, the fact that these bones healed, often severe breaks that would have incapacitated an individual for weeks or months, is powerful evidence of sophisticated social care. For a person with a badly broken leg to survive, they must have been fed, kept warm, and protected by their group. This is not the sign of a society where the weak are simply left behind. It points to strong social bonds, empathy, and a collective investment in the well-being of each member. What looks like brutality at first glance can also be read as evidence of compassion. Now consider the evidence for nutritional stress, the lines on the bones and teeth. The conventional view sees this as proof of chronic, near-constant hunger. An alternative interpretation is that it reflects periodic seasonal scarcity rather than year-round desperation. Most ecosystems have a lean season. For hunter-gatherers, this might have been the late winter, when stored food ran low and new growth had not yet begun. The skeletal markers might be recording these predictable bottlenecks, not a constant state of starvation. This would suggest a life that pulsed between periods of abundance, like after a successful mammoth hunt, and periods of intense hardship. It's a different rhythm of life, one of feast and famine, but not necessarily one of unceasing misery. Finally, let's look at the environment. The intense cold was a real danger, but humans are remarkably adaptable. Through technology, tailored clothing, well-designed shelters, and behavior, they could create microclimates of comfort. We know from finds like the 25,000-year-old burials at Sungir in Russia that people were adorned with thousands of ivory beads, which must have been sewn onto sophisticated, tailored clothing made of hides and fur. This wasn't just a loose wrap, it was complex apparel, likely including trousers, parkas, and boots. Furthermore, the human body itself can adapt. People who live in cold climates today exhibit physiological adaptations, like increased metabolic rates, that help them stay warm. Ice Age people would have been biologically and culturally fine-tuned to their environment. What seems impossibly harsh to us, accustomed to central heating, might have been their baseline normal. By placing these interpretations side by side, we can see that the evidence is often ambiguous. It doesn't speak for itself, it has to be interpreted through a model. The brutish life model and the resilient life model are not necessarily mutually exclusive. The reality was likely a complex mixture of both. The key is to hold the tension between them, to resist the urge for a simple, single story, and to remain aware of the profound gaps in our knowledge. How do we know what we think we know? This is a crucial, meta-level question we need to address. Our entire picture of the Ice Age is built on fragments, and the way those fragments were created, preserved, and found shapes everything we can say. This is a question of methodology and bias. First, let's consider the instruments of detection. Our main instrument is archaeology. Archaeologists excavate sites, carefully recording the location of every stone flake and bone fragment. But what gets preserved? Stone, bone, ivory, and ceramics, in later periods, survive well. Wood, leather, plant fibers, and textiles almost never do. This is called preservation bias. Our picture of the past is overwhelmingly skewed towards the inorganic. We have tens of thousands of stone tools, but only a handful of wooden spears. We know they made clothing because we have the bone needles they used to sew it, but the clothing itself is gone. We are trying to reconstruct an entire world from its most durable garbage. We must constantly ask, what is missing from this picture? What would change if we could see the baskets, the ropes, the carvings in wood, the patterns on the clothes? Second, there is the issue of survivorship bias. The sites we find are the sites that have survived tens of thousands of years of erosion, glaciation, and geological change. Many coastal sites where marine resources might have been abundant are now deep underwater due to sea level rise. River valley sites may have been washed away by floods. What we are left with is a non-random sample of what once existed. The cave sites of Europe are famous because caves are excellent preservation environments. But did most people live in caves? Probably not. Most likely lived in open-air shelters made of wood, bone, and hide, the ephemeral remains of which are much harder to find and interpret. We are studying the survivors, both in terms of artifacts and locations, and that can distort our understanding. Finally, we have to consider the limits of what our analytical techniques can tell us. We can analyze the chemical isotopes in a bone to know what an individual ate in the last decade of their life, but we can't know what they believed about the world. We can reconstruct the sequence of strikes used to make a stone tool, but we can't know what the maker was thinking. There is a vast realm of social life, of belief, of language, of emotion that is almost entirely invisible to the tools of archaeology. We are like detectives arriving at a crime scene 20,000 years late, with only a few scattered durable clues left. This is not a reason for despair. It is a reason for intellectual caution and creativity. It means we must be explicit about our assumptions and transparent about the immense uncertainties, and it forces us to reopen our main thread with this in mind. Every piece of evidence we examine is a survivor, a fragment, a whisper from a world that was infinitely richer and more complex than the pieces it left behind. The language we use to describe the past is not neutral. Our words are tools, and like any tool, they shape what we can build. The choice of a single verb can subtly inject modern assumptions and biases into our interpretations of Ice Age life. Let's examine how our framing can shape our inferences. One of the most common pitfalls is the use of anthropomorphic language when describing systems or people. We might say that a group of hunters conquered the mammoth steppe or waged war against the cold. These words imply a relationship of conflict, of domination. They frame the story as an epic struggle of man versus nature. But what if we replace those verbs? What if we say they inhabited the mammoth steppe or adapted to the cold? This changes the entire dynamic. It suggests a relationship of attunement, of belonging, of participation. It moves from a story of opposition to one of integration. The evidence on the ground, the deep knowledge of animal behavior, the use of local materials, arguably supports the second framing more than the first. Another area to watch is the language of progress. It is very easy to describe technological changes as a linear progression from primitive to advanced. We might talk about crude, early hand axes and sophisticated later blades, but these labels are value judgments. Was a simple, quickly made flake tool used to butcher a small animal any less fit for purpose than a finely crafted Solutrean point? The simpler tool might have been the more elegant solution in that context, maximum utility for minimum effort. Describing technology as a series of solutions to specific problems is often more accurate than framing it as a ladder of progress. Metaphors are also powerful, but they have their limits, and we must be explicit about them. We might talk about a cave painting as a language or a burial as a text. These metaphors can be useful, helping us think about symbolic communication, but we must immediately clarify their limits. We don't know the grammar of their symbolic system. We can't read the paintings in any literal sense. We are seeing patterns and guessing at their meaning. By explicitly stating this is an analogy and here is where it breaks down, we can use the power of the metaphor without falling into the trap of believing it is a literal description of reality. By being mindful of our words, by replacing verbs of conflict with verbs of attunement, by avoiding the teleology of progress, and by carefully policing our metaphors, we can build a more cautious, more nuanced, and likely more accurate model of the past. It's a discipline of language that forces a corresponding discipline of thought. Now let's try to apply some of these ideas in a concrete, step-by-step walkthrough. Let's place you inside a moment using the principles from our first evidence track, patterns at the human scale. Imagine you are in a small river valley in what is now southern France, about 24,000 years ago. It is late autumn. The air is cold and sharp, and the leaves of the dwarf willows along the riverbank are a pale, brittle yellow. Your small family group, perhaps 15 people, has just arrived at this spot, a place you return to every few years. Your first task is shelter. You are not looking for a cave. You are looking for a place with specific resources. You find a spot on a south-facing slope, sheltered from the prevailing north wind by a limestone outcrop. Here, the sun, low in the sky, will provide a little warmth during the day. The river is nearby, providing water, and you can see a long way down the valley, which is crucial for spotting game animals or other human groups. This is the first step, reading the landscape, choosing a location based on a complex set of variables: wind, sun, water, visibility. This is an act of applied knowledge. Next, the structure. Some members of your group begin to gather materials. They harvest long, straight poles from a thicket of juniper. Others use heavy stone choppers to break the leg bones of a bison that was hunted a few days ago. You are building a hut, a temporary dwelling. The large bones are driven into the ground to form a sturdy frame. The poles are laid against them, forming a conical shape. This is the skeleton. This is an act of engineering using the materials at hand. Now the skin. You and others bring out the large, heavy hides of the bison, carefully preserved from the hunt. They are draped over the frame, overlapping to shed water and block the wind. Heavy stones are placed around the bottom edge to hold them down. The entrance is a simple flap oriented away from the wind. Inside, the ground is scraped flat, and in the center, a shallow pit is dug and lined with stones for a hearth. You have created a microclimate, a bubble of relative warmth and safety. Finally, the interior. Dried grasses and mosses are brought in to create an insulating floor. Furs and smaller hides are laid down for bedding. A small pile of dried animal dung and precious firewood is stacked near the hearth. A supply of stone nodules for tool-making is placed in a corner. You have not just built a shelter, you have organized a living space. This entire process, from reading the land to furnishing the hut, is a concrete chain of causality. Every action is purposeful, based on knowledge passed down through generations. It is a sequence of problem-solving, a quiet display of immense competence. This is the human scale of survival, not a dramatic battle, but a series of thoughtful, skillful and cooperative acts that transform a piece of the landscape into a temporary home. Let's apply the same template, but now shift the scale using the lens of our second evidence track, systems and feedbacks. We'll move from the immediate construction of a shelter to the longer-term system that makes that shelter possible and necessary. Let's stay with your group in that same river valley, but zoom out in time and space. The bison hides you used for your shelter did not just appear. They are the product of a much larger system. Months earlier, your group was part of a larger gathering, perhaps 100 people, who came together for a communal hunt. This hunt was timed to intercept the seasonal migration of bison herds. This timing wasn't accidental. It was the result of generations of observation, encoded in stories and calendars, likely based on the moon or the position of certain stars at sunrise. The hunt itself was a complex, coordinated effort. It wasn't a chaotic free-for-all. It likely involved using the landscape itself as a tool, driving the animals into a natural cul-de-sac or a prepared ambush site. This required deep knowledge of animal behavior and seamless cooperation between dozens of individuals. Here we see a feedback loop. A successful hunt reinforces the social bonds and the shared knowledge base, which in turn makes future hunts more likely to succeed. The number of animals taken was also likely a carefully regulated decision. Taking too many would deplete the herd and jeopardize future hunts. Taking too few would mean not having enough resources, meat for food, hides for shelter and clothing, bones for tools and fuel, to survive the coming winter. The group's decision-making process, whatever form it took, had to be sensitive to the long-term health of the bison population. They were managing a resource, participating in the predator-prey feedback loop we discussed earlier. Now let's scale out even further. The very existence of these vast bison herds was dependent on the continental-scale climate system. The cold, dry conditions of the last glacial maximum created the mammoth steppe, the vast grassland that fed the herds. The health of that grassland was, in turn, dependent on the animals themselves. Their grazing prevented forests from taking over, and their waste returned nutrients to the soil. This is a biome-level feedback system. The animals and the grasses created and maintained each other. Your small group, building a hut from bison hides, is a tiny but essential component of this vast, interconnected system that spans from a single hearth to the planetary climate. Your immediate actions are constrained and enabled by the dynamics of the herd, which are constrained and enabled by the dynamics of the biome, which are constrained and enabled by the tilt of the Earth's axis. This scale shift from the micro, building a hut, to the macro, planetary climate, reveals that survival was not just a set of local skills. It was about being successfully nested within multiple layers of interacting systems, understanding and adapting to the rhythms of each. Let's zoom out to the largest possible scale of physical interaction, the dance between the Earth and the Moon. This might seem far removed from the question of human survival, but this coupling provides a powerful archetype for how planetary stability is maintained, creating the predictable environment in which life can flourish over geologic time. The Earth and Moon are locked in a gravitational embrace. One of the most obvious consequences of this is the tides. The Moon's gravity pulls on the Earth's oceans, creating bulges of water that we experience as high tides. As the Earth rotates underneath these bulges, it encounters friction, both within the water itself and between the water and the seafloor. This constant tidal friction acts as a brake on the Earth's rotation. It is an incredibly slow but relentless process. Billions of years ago, a day on Earth was much shorter, perhaps only 6 hours long. The Moon was also much closer to the Earth. Over geologic time, this tidal braking has slowed our planet's spin to the 24-hour day we now experience. In this process, angular momentum must be conserved. As the Earth's rotation slows, the Moon slowly drifts farther away from us at a rate of about 3.8 centimeters per year, roughly the speed your fingernails grow. This is rotational damping. The Earth-Moon system is gradually losing rotational energy, settling into a more stable, lower energy state. Why is this important? The Moon's gravitational influence does more than just cause tides. It acts as a giant stabilizer for the Earth's axial tilt, also known as its obliquity. The Earth is tilted on its axis by about 23.5 degrees, and this tilt is what gives us our seasons. The gravitational pull of the Sun and other planets, especially Jupiter, tries to tug on the Earth's equatorial bulge, which could cause this tilt to wobble chaotically over long periods. Mars, which lacks a large moon, has an axial tilt that has varied wildly, from nearly 0 degrees to over 60 degrees. This would create catastrophic climate swings, making it very difficult for complex life to persist. Our large moon acts as a gravitational anchor. It dampens these external perturbations, keeping our axial tilt relatively stable, wobbling only slightly over tens of thousands of years. This planet-moon coupling is a fundamental mechanism of planetary regulation. It provides a long-term, predictable framework of days, seasons, and climate stability. This stability is the bedrock upon which the slower rhythms of life, including the evolution of a species that can plan and remember, are built. How do we translate the abstract physics of planetary coupling into the lived reality of Ice Age survival? The consequences are profound, shaping the very rhythm of life. The stable axial tilt, courtesy of the Moon, is the reason the seasons are predictable. For a hunter-gatherer, this predictability is everything. It means you can know with reasonable certainty that the salmon will run in the rivers in the spring, that the berries will ripen in the late summer, and that the migratory herds will move south in the autumn. This regularity allows for long-term planning. It allows for the development of a cultural calendar, a body of knowledge about when to be where that can be passed down through generations. Without this predictable seasonal pulse, life would be a chaotic scramble, reacting to environmental changes that have no pattern. The long-term stability provided by the Moon allows for the establishment of a reliable memory of the environment. The second consequence is the length of the day. The 24-hour day-night cycle, slowed by tidal friction over eons, sets a fundamental tempo for life. It dictates the patterns of activity for both humans and the animals they depend on. Diurnal animals are active during the day, nocturnal ones at night. Human hunting strategies had to be tuned to this rhythm. The length of daylight in summer versus winter at high latitudes would have dramatically shaped the pattern of life, with long, active summer days for hunting and gathering, and long, dark winter nights for social bonding, storytelling, and craft production inside a shelter. This daily cycle is so fundamental that it is built into our very biology, our circadian rhythms. This planetary timekeeping, from the daily spin to the annual tilt, provides the essential, stable framework for a habitable world. It creates a predictable stage on which the drama of life can unfold. For the people of the Ice Age, this planetary clockwork was not an abstract concept. It was written in the sky, in the movement of the sun, the phases of the moon, the turning of the constellations. It was written on the land, in the freezing and thawing of rivers, the budding of plants, the arrival and departure of animals. The consequences of this macro-scale coupling were felt in the most intimate aspects of their lives, in the timing of a hunt, the telling of a story, and the very rhythm of their breath as they slept through a long, predictable night. Planetary habitability is not just about having the right ingredients like water and air. It's about having stability and predictability over immense stretches of time. How do we know about the deep past? How do we read the history of a planet? We look for archives, for places where information has been recorded and preserved. Nature creates these archives in many forms, and learning to read them is one of the great achievements of modern science. This provides another track of evidence, one based on memories stored over deep time. One of the most important archives is sediment. In the deep ocean, far from the turbulence of the coasts, a slow, constant rain of particles falls to the seafloor. This includes dust blown from the continents, the shells of tiny marine organisms called foraminifera, and volcanic ash. Layer by layer, century by century, this material builds up, creating a continuous record of Earth's history. Scientists can drill deep into the ocean floor and extract sediment cores, which are like long, striped cylinders of mud. Each layer is a page in the archive. The chemical composition of the tiny shells, for example, can tell us about the temperature and chemistry of the ocean at the time they were formed. The amount of dust can tell us how arid and windy the continents were. By reading these signals up and down the core, we can reconstruct past climates with astonishing detail. Another crucial archive is ice. In places like Antarctica and Greenland, snow that falls each year is buried and compressed into ice, trapping tiny bubbles of the ancient atmosphere. By drilling ice cores, some of which are miles long and go back 800,000 years, we can directly measure the composition of the atmosphere in the past. We can count the layers to create a precise timeline and analyze the trapped air to know the levels of greenhouse gases like carbon dioxide and methane. The isotopic composition of the ice itself acts as a thermometer, telling us the local temperature when the snow fell. These ice cores are like a high-fidelity recording of the planet's breath. These archives, sediment and ice, act as lagging indicators. They are recording the consequences of changes in the Earth's systems. They don't tell us the why directly, but they give us an incredibly detailed what and when. They show us the rhythms and patterns of the planet's climate over hundreds of thousands of years. They reveal the great cycles of ice ages, the regular, clock-like pulse driven by subtle changes in Earth's orbit, known as Milankovitch cycles. And they also show us abrupt, chaotic climate shifts, times when the system seemed to lurch violently from one state to another. These natural archives provide the essential context for understanding the world our Ice Age ancestors inhabited. Their lives were lived within the patterns revealed by these deep, silent records. What can we and what can we not infer from these archival signals? What are the constraints on our knowledge? The strength of these archives, like ice cores and ocean sediments, is their ability to provide a continuous quantitative record of large-scale environmental parameters. We can, with a high degree of confidence, state what the atmospheric CO2 concentration was 20,000 years ago. We can map the extent of the northern hemisphere ice sheets with reasonable accuracy. We can determine the global average sea level to within a few meters. This provides the essential, non-negotiable physical framework. It sets the boundary conditions for any model of human life. For example, knowing that sea levels were 400 feet lower tells us that we must look for evidence of human occupation on the exposed continental shelves, areas that are now inaccessible. Knowing that the world was dustier and drier helps us understand the prevalence of grassland ecosystems. These are powerful, top-down constraints. However, the limitation of these archives is their scale. An ice core from Greenland tells us about the average temperature in the North Atlantic region. It doesn't tell us about the specific weather in the Dordogne Valley on a particular Tuesday. Global sea level is an average. It doesn't tell us the local details of a specific coastline. There is a gap between the coarse-grained, continental-scale picture provided by the archives and the fine-grained, local experience of a small band of people. We can't infer their lived experience directly from the ice core data. The archives can tell us that the climate changed abruptly, but they can't tell us how people responded. Did they move? Did they change their hunting strategy? Did their social structures adapt? Did they create new myths and stories to explain the changing world? The archives are silent on these human-scale questions. This is where archaeology comes in, providing the ground truth, the human-scale data points that we can try to place within the larger context provided by the paleoclimate records. So our confidence bands are wide. We can be highly confident about the general environmental backdrop. We can be moderately confident about how regional ecosystems might have responded, but when we get to the level of specific human behaviors and beliefs, our confidence is much lower. We are moving from measurement to inference, from data to interpretation. The key is to be honest about this transition and to always remember that we are trying to connect two very different kinds of records: the high-fidelity but impersonal archive of the planet and the sparse, fragmented, but deeply human archive of archaeology. As we continue to build our model, adding layers of evidence from planetary systems and deep time archives, it's worth pausing to flag a synthesis that is beginning to take shape. We have looked at evidence on the human scale, the skill in a single stone tool. We have looked at the scale of ecosystems, the dance of predator and prey. We have looked at the planetary scale, the stabilizing embrace of the moon, and we have looked at the scale of deep time, the memories stored in ice and mud. These are not separate stories. They are interconnected levels of a single, complex system. The challenge and our goal in the later part of our journey tonight will be to see how they fit together. How does the long, slow rhythm of planetary mechanics create the stage for the faster rhythm of ecological change, which in turn shapes the immediate, daily choices of a human being? We are beginning to assemble the pieces of a multi-layered answer to our central question. It's an answer that involves not just flint and fur, but orbital mechanics and ocean chemistry. We will return to this work of integration later on. For now, just hold the thought that these different evidence tracks are not parallel lines, but threads that we will eventually weave together. The story of survival is a story of connection across all these scales. Let's turn our attention to another crucial feedback system, one where life itself is a primary driver of planetary conditions, the conversation between biomes and the atmosphere. It's a system where the living world actively shapes its own climate. A classic example is the relationship between a large forest, like the Amazon rainforest, and the rainfall it receives. A single large tree can pull hundreds of gallons of water from the ground and release it into the atmosphere through its leaves in a process called transpiration. A vast forest is like a giant atomizer, pumping enormous quantities of water vapor into the air. This water vapor then forms clouds, which in turn produce rain. In a very real sense, the forest creates its own rainfall. A significant portion of the rain that falls on the downwind side of the Amazon is water that has been recycled by the forest itself multiple times. This is a powerful positive feedback loop. The existence of the forest promotes the rainy conditions that the forest needs to survive. But this is not just about water. Trees also release microscopic particles, volatile organic compounds that can act as seeds or cloud condensation nuclei around which water droplets can form more easily, further enhancing cloud formation and rainfall. The biome, the collective of living organisms, is not a passive recipient of the weather. It is an active participant in creating it. We can see a similar, though different, dynamic at play on the mammoth steppe. The vast grasslands covering millions of square miles would have had a very different relationship with the atmosphere than a forest does. Grasslands have a higher albedo, they are more reflective than dark forests. This means they reflect more of the sun's energy back into space, which has a net cooling effect on the region. The grasses and the grazing animals also played a role in nutrient cycling. The constant grazing and manuring by mammoths, bison and horses would have returned nutrients to the soil quickly, promoting rapid grass growth in the short growing season. There's also a fascinating hypothesis related to the megafauna themselves. These large animals would have released significant amounts of methane, a potent greenhouse gas. While this may seem counterintuitive in a cold period, this biological methane production could have acted as a small but important feedback, perhaps preventing the climate from getting even colder. In these biome-atmosphere conversations, there is no intent, no planning. These are emergent properties of the system. The forest does not want to make rain. The system simply evolved in a way that coupled life and climate in a self-reinforcing loop. Understanding these conversations is crucial for understanding the Ice Age world because it shows that the environment was not a static backdrop, but a dynamic, co-created stage. What happens when these conversations, these feedback loops, break down? Systems that are maintained by self-reinforcing loops are often very resilient, but they can also have thresholds or tipping points. Once a system is pushed past a certain point, it can rapidly shift to a new, different stable state. This is a crucial concept for understanding both the stability and the fragility of the Ice Age world. Let's go back to the rainforest example. If you start cutting down the forest at first, not much might change. The remaining trees can still recycle enough water to maintain rainfall, but if you cross a certain threshold of deforestation, the system can no longer generate enough of its own rain. The climate becomes drier, the remaining forest becomes stressed, more susceptible to fire. Fires cause more deforestation, which leads to even less rain. The positive feedback loop that once maintained the forest flips and becomes a positive feedback loop that destroys it, rapidly converting the area to a drier savanna. This is a tipping point. The mammoth steppe biome likely had similar thresholds. It was a system maintained by a specific combination of cold, aridity, and a large population of grazing megafauna. What would happen if one of these parameters changed? At the end of the last glacial period, the climate began to warm rapidly. This warming had several effects. It allowed forests to expand northward, encroaching on the grasslands. It changed patterns of rainfall. These environmental shifts put the megafauna under stress. At the same time, humans who had been hunting these animals for millennia were becoming more numerous and possibly more efficient hunters. The combination of climate pressure and human hunting pressure may have pushed many megafauna species past a tipping point, leading to their extinction. Once the great grazers were gone, the ecosystem changed irreversibly. The grasslands were no longer maintained by their grazing. In many places, they were replaced by boggy tundra or dense forest. The positive feedback loop between the grasses and the grazers was broken. For the human populations that depended on the mammoth steppe ecosystem, this would have been a catastrophic failure mode. Their entire way of life, stable for thousands of years, was built on a system that, once pushed past its threshold, collapsed with shocking speed. Understanding these tipping points, these moments of rapid, non-linear change, is essential. It tells us that the world Ice Age people inhabited was not just cold, it was conditionally stable. Its resilience had limits. To explore the idea of resilience further, let's use a carefully caveated analogy. Biology as a form of code. Think of an organism's DNA as a kind of operating system, a set of instructions for building and running a biological machine. This OS has been developed and debugged over billions of years of evolution, a process of trial and error. The environment is constantly testing the code, and only the versions that work well enough to reproduce get passed on. Now think of the cultural knowledge of an Ice Age human group as a layer of software running on top of that biological OS. This software includes language, tool-making techniques, social rules, and ecological knowledge. It's the how-to manual for living in a specific time and place. This software is not static. It is constantly being updated. A new way of hafting a spear point is like a small patch that improves performance. A story that encodes information about a distant water source is a crucial piece of data. This cultural software is what made humans so adaptable. While their biological hardware was slow to change, their cultural software could be updated very rapidly, within a single generation. Now here is the essential caveat. This analogy can be misleading if taken too literally. Unlike computer code, biological and cultural systems are not designed by an intelligent engineer. They are emergent, messy, and often contain redundancies and inefficiencies that a programmer would never allow. There is no central processing unit. The computation is distributed across the entire system. A human group's knowledge is not stored in one person's head. It is distributed among all its members, embedded in their practices, relationships, and stories. The code is not a clean, linear text. It is a complex, living network of information. Despite these limits, the analogy is useful for thinking about feedback. A key principle of robust systems, both in engineering and in biology, is feedback. The system needs to be able to sense its own state and the state of its environment and adjust its behavior accordingly. For an Ice Age group, this feedback came in many forms: the hunger in their bellies, the changing behavior of the herds, the taste of a new plant, the chill of an unexpected frost. Their cultural software was essentially a complex set of if-then statements for responding to this constant stream of feedback. If the reindeer are late, then we move to the coastal camp to find seals. If a new type of stone is found, then we test it for its flaking properties. This constant process of sensing, interpreting, and responding is the essence of adaptation. What are the implications of this biology as code framework with its focus on feedback and adaptation? The most important implication is that it reframes our goal from perfection to robustness. A well-designed computer program might be perfect. It executes its task flawlessly under a specific set of conditions. But if those conditions change, if it receives an unexpected input, it crashes. Biological and cultural systems are not like that. They are not perfect. They are messy, redundant, and often inefficient, but they are incredibly robust. They can handle unexpected inputs. They can function, perhaps not optimally, but well enough across a wide range of conditions. This is resilience. Think about the human body. It has multiple redundant pathways for metabolizing energy. If one pathway is blocked, others can take over. It has a complex immune system that can adapt to novel threats. It is designed to fail gracefully, not catastrophically. The same principle applies to Ice Age cultural software. Their survival strategies likely had built-in redundancy. They didn't rely on a single food source. They had knowledge of many different plants and animals, even ones they didn't use often. These were their backup systems. If the mammoth hunt failed, they had the knowledge to hunt smaller game or to fish or to find edible roots. Their social structure also provided resilience. The sharing of food within a group buffered individuals against bad luck. If one hunter came back empty-handed, they still ate because another was successful. This is a form of social insurance. The network of relationships between different groups maintained through trade and kinship was a larger-scale buffer. If one region was experiencing a drought, people could call on relatives in another region for help. The system was adaptive, not flawless. It was built to bend without breaking. This perspective shifts our focus from admiring their supposed perfection as hunters or artisans to appreciating the clever, multi-layered design of their survival systems that prioritized robustness, redundancy, and the ability to fail gracefully. They weren't trying to build a perfect machine. They were trying to build a system that could keep running even when things went wrong. Let's travel back even further in time to a world that is almost impossible to imagine, a world that existed long before the last ice age. Let's reconstruct the sensory landscape of Pangea, the supercontinent that existed from about 335 to 175 million years ago. This deep time panorama serves as an archetype for how planetary-scale geology can create extreme and unfamiliar climates. Imagine standing in the heart of this single, immense landmass. There are no oceans nearby. In every direction for thousands of miles there is only land. The sky is a harsh, metallic blue. The sun feels hotter, more intense than you have ever experienced. The air is thin and incredibly dry. It cracks your lips and makes your throat ache. There is no scent of damp earth or green vegetation. There is only the smell of hot rock and dust. The landscape is a vast reddish desert. Giant dunes of sand, sculpted by a wind that never seems to stop, stretch to the horizon. The ground is littered with salt crystals that crunch underfoot. The silence is profound, broken only by the hiss of the wind and the occasional crack of a rock expanding in the brutal heat of the day. This is a continental interior on a scale that does not exist today. The sheer size of Pangea created a climate of unimaginable extremes. The coastal regions might have been subject to colossal monsoons, but the vast interior was starved of moisture. Weather systems originating over the single, giant Panthalastic Ocean would have rained themselves out long before they reached the continent's core. Days would have been scorching hot, while nights, under the clear, dry skies, could have been shockingly cold, with temperatures plummeting below freezing. This is a world of brutal thermal swings. What little life exists here is tough and resilient. You might see strange, seed-bearing ferns clinging to life in a dried-up riverbed, waiting for a flash flood that might not come for a decade. Perhaps you spot a small, reptile-like creature, a synapsid, an ancestor of mammals, scurrying between the rocks, its body adapted to conserve every precious drop of water. This world, the world of Pangea's interior, is a stark reminder of how geography is destiny on a planetary scale. The arrangement of the continents dictates the circulation of oceans and atmosphere, which in turn determines the climate. Rebuilding this unfamiliar world in our imagination helps us appreciate the specific and, in some ways, more benign geography of the Pleistocene. What are the climatic and biological consequences of a supercontinent like Pangea, and what does this tell us by way of contrast about the world of the Ice Age? The primary consequence of a supercontinent is the creation of extreme continentality. As we imagined, the interiors become vast, arid deserts. The mechanism is simple: moisture transport limits. Air masses moving inland from the ocean progressively lose their moisture as rain. For a continent the size of Pangea, the interior is simply too far from the ocean for any significant amount of water to reach it. This creates immense regions that are inhospitable to most forms of life. The second major consequence relates to ocean circulation. With one giant landmass and one giant ocean, the patterns of ocean currents would have been much simpler and less dynamic than they are today. There were no choke points like the Isthmus of Panama or the Indonesian archipelago to create complex, looping currents. This would have resulted in less efficient transport of heat from the equator to the poles, likely leading to hotter tropics and colder polar regions. The world's climate would have been more stratified, with steeper temperature gradients. In contrast, the world of the Pleistocene, with its multiple continents and oceans, was a much more varied and dynamic place. The fragmentation of the continents allowed for the development of complex ocean circulation patterns, like the Atlantic meridional overturning circulation, which acts as a giant conveyor belt, transporting warm water to the north and playing a crucial role in regulating the climate of the northern hemisphere. While large parts of the Ice Age world were covered in ice or were cold, arid grasslands, there were also vast regions that remained forested or supported other diverse biomes. There were no deserts on the scale of Pangea's interior. The geography of the modern world, even in the depths of an ice age, provided more refuges, more variety, and more ecological niches. Life was not constrained to the coastal fringes in the same way. The Pangea archetype serves as a useful null hypothesis. It shows us what a world with a different geological configuration looks like, and in doing so, it highlights the specific features of the Pleistocene world, its fragmented continents, its complex ocean circulation, that made it a challenging but ultimately habitable place for a species like ours to expand across the globe. To ensure our exploration remains balanced and intellectually honest, we must actively seek out and engage with the strongest criticisms and potential falsifiers of the more resilient, complex model of Ice Age life we have been building. This is the Skeptic's Corner. What evidence, if discovered, would seriously weaken or falsify this interpretation? Let's list a few potential falsifiers as clear, testable propositions. First, if widespread archaeological evidence were discovered showing a consistent and dramatic decline in human population numbers across a large geographical area, perfectly correlated with a period of climatic stress, it would strongly challenge the idea of resilience. If the data showed that populations were unable to adapt and simply died out when faced with environmental change, it would support the more brittle, nasty, brutish, and short model. So far, the genetic and archaeological evidence seems to point to continuity and adaptation, but a different pattern of evidence is conceivable. Second, if a large sample of well-preserved human skeletons from a specific region and time period were found to exhibit universally high levels of physiological stress markers, Harris lines, enamel hyperplasia, with no exceptions, and a complete absence of older individuals, e.g., over 30, it would be very difficult to argue for a thriving, stable population. This would be strong evidence for a group living at the absolute limit of biological endurance. We must concede that the existing skeletal record is sparse, and such a find is possible. Third, if we were to find evidence of widespread endemic warfare. While evidence for interpersonal violence exists, we have not yet found anything akin to fortified settlements or specialized weapons designed solely for human-on-human conflict from this period. If we started to find mass graves with clear evidence of violent death or settlements with defensive structures, it would force a major revision of the idea of small, cooperative, and relatively peaceful groups. It would suggest that intergroup conflict, not just environmental stress, was a primary driver of mortality and social organization. Fourth, a falsifier for the intimate knowledge hypothesis. If detailed analysis of animal remains at kill sites consistently showed non-selective hunting patterns, for example, the killing of entire herds, including pregnant females and juveniles, on a regular basis, this would undermine the idea of sustainable hunting practices based on deep ecological understanding and would instead point towards a less strategic, more opportunistic approach that did not prioritize long-term resource management. Each of these potential discoveries would force a serious reevaluation of the model we are exploring. Acknowledging them is not a sign of weakness in our argument, it is a fundamental part of the scientific process. It defines the boundaries of our claims and keeps our inquiry tethered to the real-world evidence. Let's pause again for a meta-method interlude. Let's think about the mindset required for this kind of deep-time detective work. We are dealing with a profoundly incomplete data set. The evidence is fragmentary, biased, and often ambiguous. How do we reason under such deep uncertainty? The key is to think like a detective who knows that most of the clues have been erased. First, we must be aware of our priors. A prior is the set of beliefs or assumptions we bring to the evidence before we even look at it. If we start with the prior that Ice Age people were primitive savages, we will tend to interpret every piece of evidence through that lens. A broken bone becomes proof of a violent life. A simple tool, proof of a simple mind. If we start with the prior that they were noble ecologists, we will do the opposite. The goal is not to have no priors, that's impossible, but to be aware of them, to state them explicitly, as we did with our assumption of competence, and to be willing to update them when the evidence contradicts them. Second, we must pay special attention to anomalies. An anomaly is a piece of evidence that doesn't fit the prevailing model. The Sungear burials, with their incredible wealth of grave goods, were an anomaly. The impossibly delicate Solutrean points are an anomaly. The deep cave paintings located in dangerous and inaccessible places are an anomaly. It's tempting to dismiss anomalies as strange one-offs, but often they are the most important clues we have. They signal that our model is incomplete or wrong. They are the cracks in the consensus through which a new understanding might emerge. Actively seeking out and thinking about anomalies is a crucial part of the process. Finally, we must constantly think about the process of erasure. We have to ask not just what is here, but what should be here but isn't. The absence of evidence can sometimes be evidence in itself, though this is a dangerous path to tread. For example, the absence of defensive structures for tens of thousands of years is a significant piece of data. Why don't we see them? What does that tell us about the nature of their society? Thinking about what has been erased forces us to confront the limits of our knowledge and to imagine the vast, invisible world of wood, fiber, and skin that existed alongside the durable world of stone. This detective mindset, managing priors, hunting for anomalies, and contemplating erasure, is our best tool for navigating the fragmentary landscape of the deep past. It allows us to reopen our main thread, not with certainty, but with a more sophisticated and honest approach to the profound uncertainty we face. Let's bring our awareness back from the vastness of deep time and the abstractions of methodology, right back into the body, into the room, where this journey began. Feel the contact points again, the weight of your head, your shoulders, your hips against the surface supporting you. Feel the gentle rise and fall of your chest or abdomen with each breath. This simple, physical reality is the same anchor they had. The experience of having a body, of feeling warmth, cold, hunger, fatigue, is a bridge across 20,000 years. While their world was unimaginably different, the internal landscape of bodily sensation was the same. Their lungs drew in cold, dry air. Yours draw in the air of your room. The fundamental process is identical. This act of grounding ourselves in the present, in our own physical being, is not an escape from the topic, but a deeper entry into it. It reminds us that the story of the Ice Age is not an abstract intellectual puzzle. It is the story of bodies, like yours, navigating a physical world. Bodies that needed to stay warm to find food, to rest. Bodies that felt fear and comfort and connection. From this grounded place, we can consider the idea of agency. Agency is the capacity to act in an environment. In our world, much of our agency is mediated by complex technologies. We flip a switch and light appears. We turn a key and a powerful engine starts. The connection between our action and the outcome is often obscured by layers of machinery. For the people of the Ice Age, agency was more direct, more embodied. To create warmth, you had to understand fire. You had to know which wood burned best, how to start a spark, how to tend a flame. To get food, you had to understand the animals and plants. You had to be able to shape a stone into a cutting edge with your own hands. This is not a prescription to abandon modern life. It is not a romanticization of hardship. It is simply an invitation to notice the texture of our own agency. Where, in your life, is the connection between your action and its outcome direct and clear? It might be in cooking a meal, in gardening, in fixing something that is broken, in playing a musical instrument. These moments of direct, embodied agency are small echoes of the world we are exploring. They are a way of connecting through our own experience to the fundamental human capacity to shape our world with our own hands and minds. Every system, from a single cell to a planetary climate, is governed by its energy budget. The flow of energy through a system determines its structure and its dynamics. Understanding this provides another powerful track of evidence for how the Ice Age world worked. Let's consider the Earth's energy budget as our archetype. The vast majority of the energy that drives the climate system comes from the Sun. This incoming solar radiation, or insolation, is the primary input. The Earth, in turn, radiates heat back out into space as infrared radiation. In a stable climate, the incoming energy and the outgoing energy are roughly in balance. If they fall out of balance, the planet will either warm up or cool down. Several key parameters can change this balance. One is the amount of incoming solar radiation. The Milankovitch cycles, the subtle, periodic changes in the Earth's orbit, tilt and wobble, alter the amount and distribution of sunlight reaching the planet. These cycles are the primary pacemaker of the ice ages. When the orbital configuration favors cooler summers in the northern hemisphere, snow and ice don't melt, ice sheets grow, and an ice age begins. Another key parameter is the Earth's albedo, or reflectivity. A white surface, like ice, reflects a lot of sunlight back into space. A dark surface, like the ocean, absorbs it. This creates a powerful positive feedback loop. As ice sheets grow, they increase the planet's albedo, reflecting more sunlight, which causes more cooling, which leads to more ice growth. The reverse is also true. As ice melts, the darker land or ocean underneath is exposed, absorbing more heat, causing more melting. A third parameter is the composition of the atmosphere, specifically the concentration of greenhouse gases like CO2. These gases act like a blanket, trapping some of the outgoing infrared radiation and warming the planet. Ice core data shows that CO2 levels were much lower during the Ice Age, around 180 parts per million compared to about 280 before the Industrial Revolution. This lower concentration of greenhouse gases was a major factor in keeping the planet cold. These parameters, insolation, albedo, and greenhouse gases, are the main control knobs of the planetary climate. Their interactions and feedbacks determine the long-term state of the system. The consequences are profound. A small change in one parameter can trigger feedback loops that lead to a massive, planet-wide state shift from a warm interglacial world to a cold glacial one. For the people living in this world, these abstract parameters define the absolute constraints of their existence. What are the implications of thinking about the world in terms of these energy budgets and feedback loops? What happens when we perform a sensitivity analysis asking what if one of these parameters was slightly different? One immediate implication is that we can identify multiple plausible mechanisms for the same event. Take the abrupt climate change events visible in the ice core records, where temperatures in Greenland could rise by 10 degrees Celsius in just a few decades. What caused these? It could have been a sudden change in ocean circulation, flipping the switch on the Atlantic conveyor belt. It could have been a massive release of methane from thawing permafrost. It could have been a rapid retreat of sea ice, triggering the albedo feedback loop. It's likely a combination of these and other factors. The system is so complex and interconnected that multiple pathways can lead to the same outcome. This creates an uncertainty budget for our explanations. We can't be certain which mechanism was the primary driver. We can only say that the system was highly sensitive to certain kinds of perturbations during that time. This sensitivity has profound implications for the people on the ground. It means that the world they experienced was not just cold, it was potentially unstable. The long periods of relative stability could be punctuated by moments of shocking, rapid change. Their survival systems, their cultural software, would have needed to be robust enough to handle not just the predictable seasonal cycles, but also these unpredictable, high-amplitude shifts. A second-order trade-off becomes apparent here. A strategy that is optimal for a stable environment might be disastrous in a changing one. For example, becoming highly specialized in hunting a single animal species might be very efficient when that species is abundant. But if a rapid climate shift causes that species to disappear, that specialization becomes a fatal trap. A more generalized, less optimal strategy of exploiting many different food sources is more resilient in the face of uncertainty. This suggests that their risk management strategies might have prioritized flexibility over peak efficiency. They were not trying to maximize their returns in the best of times. They were trying to ensure their survival in the worst of times. The energy budget view forces us to think in terms of probabilities, sensitivities, and trade-offs, revealing a world where the primary challenge was not just dealing with the cold, but dealing with deep and sometimes abrupt uncertainty. How did people make sense of such a complex and sometimes volatile world without the tools of modern science? How did they encode and transmit their deep knowledge of the environment? One way to explore this is to look at how other, more recent, pre-literate cultures have mapped similar patterns through their stories and myths. This is not to say that Ice Age myths were the same, but to see how narrative can function as a powerful technology for storing and transmitting complex information. Let's make a modest claim. Many myths and traditional stories, which can seem like fanciful fictions to a modern ear, often contain detailed, practical observations about the natural world. For example, the myths of indigenous groups in the Arctic often feature stories about the complex relationship between the sea ice, the seals, and the polar bears. These stories are not just entertainment. They encode crucial information about animal behavior, about the dangers of the ice, and about the proper, respectful way for humans to interact with these powerful forces. A story about a trickster raven who teaches people how to find food might contain, embedded in the narrative, a map of the seasonal availability of different resources. The characters and plot make the information memorable and easily transmissible. Another pattern found in many traditional narratives is the idea of a world in flux, a world that has undergone profound transformations in the past. Creation myths often speak of a time when the landscape was different, when animals could speak, when the rules of the world were not yet set. These stories might be a cultural echo of real, observed environmental changes. A story about a great flood, common in many cultures around the world, could be a distant memory of the dramatic sea level rise that occurred at the end of the last ice age, an event that would have submerged coastal communities and radically redrawn the map of the world. These narratives also often serve to enforce sustainable practices. A story might warn that a powerful spirit will punish those who take too many fish from a river or who do not show respect for the animals they hunt. This is a mythological framing for a very practical feedback loop. It's a way of articulating the idea that human actions have consequences and that violating the rules of the system will lead to negative outcomes. By looking at mythology as a form of ecological and social code, we can begin to imagine how Ice Age people might have built and maintained their own complex knowledge systems. Their science was embedded in their stories. Their ethics were part of their cosmologies. It was a different way of knowing, but no less powerful or effective for being expressed in the language of myth rather than the language of mathematics. Let's pause and look back at the threads we have been weaving. We started with the human scale, the intimacy of a tool in the hand. We zoomed out to ecological systems, planetary mechanics, and the deep time archives of ice and sediment. We have considered the evidence, the objections, and the very language we use to frame our questions. We have touched on energy budgets, cultural software, and the way stories can encode knowledge. A common theme is emerging: the tension between binaries. We often think in terms of simple opposites: survive or die, human versus nature, stability versus change, knowledge versus myth. But our exploration so far suggests that these binaries are not sufficient. The reality is more complex, more nuanced. The lines are blurrier. Now we are approaching a turn in our journey. We are preparing to reframe these oppositions to move from either-or thinking to a more integrated model. The next step is to dissolve these hard lines and see them instead as continua, as spectrums of possibility. This shift in perspective will allow us to build a more robust and satisfying synthesis, one that can hold the complexity and the contradictions of the evidence without breaking. The turn is a simple but profound shift in perspective. It is the move away from thinking in binaries and toward thinking in spectra. Let's take the most fundamental binary of our question, survival versus extinction. It seems absolute. You either survive or you don't. But at the level of a population over time, it's not so simple. It's a continuum of resilience. A group might be thriving with a growing population and abundant resources. They might be stable with their population holding steady. They might be stressed with a slowly declining population, or they might be in a crisis on a rapid path to local extinction. These are not four separate states, they are points on a spectrum, and a group could move back and forth along this spectrum over time. A few bad years could push a thriving group into stress. A new technological innovation or a favorable climate shift could allow a stressed group to recover. The real question is not did they survive, but what factors allowed them to stay on the right side of that spectrum for so long. Now let's apply this to the human versus nature binary. We have already started to break this down. The evidence points not to a relationship of opposition, but one of deep integration. It's a continuum of participation. At one end, you could have a group that has a minimal impact, living lightly on the land. At the other end, you could have a group that is actively shaping its environment, perhaps through the systematic use of fire to maintain grasslands and promote the growth of useful plants. This is not domination. It is a form of co-creation, a dance between human agency and ecological dynamics. The lived choice for them was not do we control nature, but how do we participate in this system? Finally, consider the binary of stability versus change. The Ice Age was not one long static period of cold. It was a time of immense volatility, with periods of relative stability punctuated by abrupt, rapid change. The key to their long-term success was not living in a stable world, but having a cultural system that was plastic enough to deal with both states. They needed strategies for the stable times, the predictable herd migrations, the recurring seasonal plants. And they needed strategies for the unstable times, the fallback foods, the social networks that allowed them to move to new areas, the ability to rapidly innovate new technologies. Their cultural toolkit had to operate across the entire spectrum, from stability to chaos. By replacing these either-or categories with ranges and continua, we arrive at a more dynamic and realistic model. It allows us to see Ice Age life not as a static diorama, but as a complex, adaptive system, constantly adjusting its position along multiple spectra in response to a changing world. Now we can begin to integrate our various evidence tracks into a minimal, coherent model. This is our first pass at a synthesis connecting the micro to the macro. Let's start with the base layer, the planetary mechanics. The slow, predictable cycles of the Earth's orbit, stabilized by the Moon, set the fundamental tempo of the climate system, driving the long-term pulse of glacial and interglacial periods. This is the deep bass note of the story. It is the ultimate context. On top of this, we layer the Earth system's feedback. The lower CO2 levels, the high albedo from the ice sheets, and the altered ocean circulation created and maintained the cold, arid conditions of the last glacial maximum. These global parameters created the specific environmental stage of our period, the mammoth step. This stage was not static. It was subject to abrupt shifts and tipping points when the climate system lurched from one state to another. Now we place the biome onto this stage. The mammoth step was a co-creation of the climate and the life within it. The grasses and the giant herbivores existed in a feedback loop, each sustaining the other. This ecological system provided the primary resources and constraints for the human actors. Finally, we arrive at the human scale. A small, mobile group of Homo sapiens is navigating this complex, multi-layered world. Their survival depends on their ability to operate successfully across all these scales. Their biological hardware, their brains and bodies, is the product of deep evolutionary time. But their key advantage is their cultural software. This software is a multi-layered toolkit. At the most immediate level, it contains the practical skills for toolmaking, shelter construction, and finding food. The things we see in the archaeological record. This is the micro level. But this toolkit also operates at the macro level. It contains a deep, multi-generational understanding of the ecological systems they are part of, the predator-prey dynamics, the cyclical nature of resources. This knowledge allows them to manage their impact and maintain the long-term health of the resources they depend on, and their software may even have contained an awareness of the deeper, slower rhythms of climate change, encoded in myths and stories of a world that was different in the past. Their social structure, based on cooperation, sharing, and extensive kinship networks, provided the resilience needed to buffer against both local misfortunes and large-scale environmental shocks. In this model, the laurel leaf point is not just a beautiful object. It is a product of a mind that could think abstractly, a society stable enough to support artistry, an ecosystem rich enough to provide the resources and time, all unfolding on a planet whose specific orbital configuration made that ecosystem possible. The synthesis avoids triumphalism. It shows humans not as masters of the world, but as supremely skilled and adaptable participants within it. A good model must not only explain what we see, but also honestly acknowledge what it cannot explain. This second pass at synthesis is about reconciling the counterpoints and being explicit about our uncertainty. Let's return to the Steelman argument, the evidence for a hard life. Our model of resilience and complexity does not erase this evidence, it must incorporate it. The Harris lines, the healed fractures, the high infant mortality, these are real. The synthesis suggests that life was a paradox. It was simultaneously incredibly harsh and dangerous at the individual level, while being remarkably stable and successful at the population level over the long term. Their cultural systems were strong enough to carry their populations through the immense filter of individual hardship. Success was not the absence of suffering, it was the continuity of the group despite that suffering. The model does not propose a utopia. It proposes a system that was effective, not perfect. What remains unknown? The gaps are immense. The biggest unknown is the inner world of Ice Age people. What was the content of their beliefs? We can infer function, that their stories encoded ecological knowledge, but we cannot know their meaning. The cave paintings are a profound mystery. Were they hunting magic, shamanic visions, historical records, teaching tools? We have dozens of hypotheses, but no way to test them. They remain a powerful symbol of how little we can know about their spiritual and intellectual lives. Another major area of uncertainty is social and political organization. We talk of small, mobile, egalitarian groups, and this is likely true for the most part. But was it always true? Could more complex hierarchical societies have emerged for brief periods in resource-rich areas? What were the mechanisms for resolving conflict? How were decisions made? The archaeological record is almost entirely silent on the fine-grained details of their social dynamics. We also need to map our next tests. How can we reduce our uncertainty? Advances in ancient DNA analysis are revolutionizing the field. By sequencing the genomes of more individuals, we can build much more detailed pictures of population movements, family structures, and genetic adaptations. Advances in chemical analysis of artifacts and sediments, residue analysis on tools, lipid analysis in pottery, can give us more direct evidence of what people were eating and how they were processing it. The continued search for sites with exceptional preservation, especially in waterlogged or frozen environments, holds the promise of finding the organic materials that are usually lost. This synthesis, then, is a provisional one. It frames their success as a triumph of cultural and social resilience in the face of constant individual risk. But it holds a large and explicit space for what we do not know, especially about the rich tapestry of their inner and social worlds. Let's walk through one final case template, applying our synthesized model to a specific, vivid scenario. We are moving beyond simple causality to see how the different layers of the model interact. You are part of a group living near the edge of the northern ice sheet in a world of long, dark winters. It is a time of particular hardship. For the last several years, the climate has been colder and more volatile than usual. The animal herds, your primary source of food, have become less predictable in their movements. Your group is in the stressed part of the resilience spectrum. The immediate human-scale problem is a shortage of food and fuel for the winter. Your stored supplies are running low. The micro-level response is to change your hunting strategy. Instead of focusing on large game, you shift to trapping smaller, more reliable animals like Arctic fox and hare. You also spend more time ice fishing in the frozen rivers. This requires a different set of tools and knowledge. The skill to make a delicate bone needle for sewing a warm parka is different from the skill to make a heavy spear point, but both are part of your cultural toolkit. This is your system's built-in redundancy at work. But this is not enough. The stress is affecting the group's social fabric. Tensions are higher. The social scale response is to activate your wider network. A small party is sent on a long, dangerous journey to a related group that lives several hundred miles to the south in a more sheltered valley. They carry with them a gift, not something practical, but something of high social value, perhaps a set of carefully matched fossil shells or a beautifully carved piece of ivory. This is not a simple trade. It is an appeal to the bonds of kinship and mutual obligation that have been maintained for generations. This is your social insurance policy being called upon. The journey is guided by stories, by songs that act as maps, describing the landscape and the route. This is your knowledge system in action. The southern group agrees to help, sharing some of their food stores and allowing your group to move into their territory for the rest of the winter. This act reinforces the social bond between the two groups. In the spring, things improve, the climate stabilizes, and the herds return. Your group moves back to its own territory, carrying with it the memory of the hardship and the knowledge that its survival depended not just on its own skills, but on the strength of its social network. This walkthrough shows the synthesis in motion. The problem is triggered by a macro-level climate shift. The solution involves a cascade of responses at the human, technological, social, and knowledge scales. It is a story of flexibility, cooperation, and the power of a resilient, multi-layered cultural system to navigate a world of deep uncertainty. How can we translate this vast, abstract model into something tangible, something that touches our own lives? This isn't about learning to knap flint or track mammoths. It's about finding small, testable practices that allow us to cultivate some of the same underlying qualities of attention and agency without moralizing or prescribing a new way to live. It's about a local-first framing. One practice is to cultivate a deeper awareness of your immediate environment. Choose one small aspect of your local ecosystem, a single tree you pass every day, the birds that visit your window, the way the light changes at a certain time of afternoon. Pay attention to it. Notice its small changes through the seasons. Learn to identify one or two local plants or bird calls. This is not about becoming a master naturalist. It is about practicing the skill of deep observation, of seeing the world not as a static backdrop but as a living, dynamic system. It is an exercise in re-enchanting the ordinary. Another practice is to engage in an act of direct, embodied agency. Fix something that is broken instead of replacing it. Cook a meal from scratch. Try to grow a simple herb on a windowsill. These activities reconnect your actions to their outcomes in a clear, physical way. They rebuild the feedback loop between your hands, your mind, and the material world. It is a small act of remembering that you are not just a consumer of systems, but a participant and a creator. A third practice relates to knowledge and time. Learn a single story, a folk tale, a family story, a piece of local history, well enough that you could tell it to someone else. Stories are a technology for storing and transmitting complex information and meaning. The act of learning and telling a story exercises a different part of your mind than consuming data from a screen. It connects you to a much older human tradition of shared oral culture. These are not grand gestures. They are small, quiet practices. They are experiments in attention. They don't promise to solve anything, but they offer a way to gently recalibrate your own perceptions, to feel, in a small but tangible way, a connection to the fundamental human capacities for observation, creation, and connection that allowed our ancestors to navigate their world so successfully for so long. What does the future hold for our understanding of this deep past? Our exploration is not over. In many ways, it is just beginning. We can sketch out a few plausible scenarios and open questions that will likely drive the research for years to come. One major future direction is the integration of climate science and archaeology at an ever finer scale. As our climate models become more powerful and our paleoclimate data more detailed, we will be able to move from reconstructing the average climate of a region to simulating its weather. We might be able to model the likely storm tracks, the severity of the winters, and the length of the growing seasons in specific valleys at specific times. When we overlay the archaeological data onto these high-resolution environmental models, we will be able to ask much more specific questions about how human groups responded to particular environmental opportunities and stresses. Our confidence level here is high. This is a direct extension of current trends. A second, more speculative direction involves a deeper understanding of the cognitive world of Ice Age people. While we may never be able to read their minds, a combination of genetics, neuroscience, and archaeology could offer new insights. For example, by understanding the genetic basis for cognitive traits and tracking how the frequency of certain genes changed over time, we might be able to make tentative inferences about the selective pressures on human cognition. Did the volatile climate of the Pleistocene select for brains that were particularly good at dealing with uncertainty? This is highly speculative, and we must be extremely cautious about genetic determinism, but it is a line of inquiry that is becoming possible. The biggest open questions remain stubbornly social and symbolic. Will we ever crack the code of Paleolithic art? Will we find new sites with unprecedented preservation that open a window into their organic world? Perhaps the most profound open question is about their disappearance. Not the extinction of the species, but the end of the hunter-gatherer way of life as the dominant human mode of existence. The transition to agriculture at the end of the Ice Age was the single most significant shift in human history. Why did it happen? Was it a response to population pressure, a consequence of climate change, or something else entirely? Understanding why this incredibly successful, resilient, and long-lasting way of life was eventually replaced is the final and perhaps most difficult chapter in the story of the Ice Age. After this long journey through evidence, models, and deep time, how do we feel? What is the emotional resonance of this intellectual exploration? Let's reframe what we have learned into a felt meaning, using a calm cadence and low-heat language. Perhaps the first feeling is one of humility. To contemplate the sheer scale of time we have been discussing, tens of thousands of years, is to recognize the brevity of our own lives and our own historical moment. The world we inhabit, with its particular climate and configuration, is a fleeting arrangement. The deep past teaches us that change is the only constant. The stability we experience is a temporary gift. This humility is not diminishing, it is clarifying. It frees us from the anxiety of believing that our current moment is the ultimate or final state of human existence. A second feeling might be a quiet sense of awe. Not a dramatic, overwhelming awe, but a gentle wonder at the elegance and complexity of the systems we have discussed, from the intricate dance of the Earth and Moon to the delicate feedback loops of a biome. There is a deep beauty in the way these systems function, a beauty that exists entirely without human awareness or intention. To appreciate this is to feel a connection to a world that is much larger, older, and more complex than our own immediate concerns. Finally, and perhaps most importantly, this exploration can lead to a feeling of profound belonging. It is easy to feel disconnected, to feel that modern life has separated us from the natural world. But this story tells us that we are not, and can never be, separate. The same planetary rhythms that govern their lives still govern ours. The same biological hardware that they possessed is humming away inside us right now. The capacity for resilience, for cooperation, for making art, for telling stories, these are not things they had that we have lost. They are our inheritance. To study their lives is to study the deepest parts of ourselves. It is to remember that we are not just observers of the Earth's story, but participants. We are a part of its complex, ancient, and ongoing conversation. The feeling is not one of romantic nostalgia for a lost past, but one of a quiet, grounded connection to a story that is still unfolding, a story that includes us. We are approaching a boundary, the line where data and models give way to questions of ultimate meaning. Science can tell us a great deal about the how of Ice Age survival. It can describe the climate, the tools, the diet, the genetics. It can build plausible models of how their societies might have functioned. But it cannot and should not answer the why. Why do we create art in the face of hardship? What is the nature of human consciousness that it can reflect on its own existence and its own deep past? What is our ultimate purpose, if any, in this vast and ancient universe? These are the questions that science brings us to, but cannot take us through. This is the philosophical boundary. To hold these questions open without rushing to fill them with easy answers is an act of intellectual and emotional maturity. Does the incredible, fine-tuned resilience of life on Earth point to some underlying purpose or design, or is it the result of billions of years of random mutation and natural selection, an astonishing but ultimately blind process of emergence? The evidence we have can be used to support either view. A person of faith might see the hand of a creator in the elegant stability of the Earth-Moon system. A secular humanist might see a testament to the undirected power of physical laws and evolutionary processes. The model we have built tonight does not and cannot adjudicate between these two interpretations. Its job is to describe the mechanism, not to assign ultimate meaning to it. The most honest and productive position, perhaps, is to simply sit with the question, to hold the mystery, to feel the full weight of the wonder that the universe and our own existence within it evokes. We can stand at this boundary and appreciate the view without needing to claim ownership of the land on the other side. The data can take us this far and no further. The rest of the journey is one of personal reflection, of philosophy, of wonder, and that is a journey we each must take for ourselves. Let's linger at this boundary for a moment and examine these two great frames for interpreting the world, design versus emergence. We can do this not as a debate to be won, but as a parallel, non-combative comparison, acknowledging that both can be approached with a sense of humility. The frame of design, in its broadest sense, looks at the intricate complexity of the world and infers a purpose, an intention, a designer. From this perspective, the fact that the Earth is so perfectly suited for life, with its stable orbit, its large moon, its magnetic field, its abundance of water, is not a series of happy accidents. It is evidence of a deeper logic, a guiding intelligence. The astonishing resilience of life, its ability to adapt and thrive in the harshest of conditions, is seen as a reflection of this purposeful design. The human capacity for consciousness, for art, for love, is not a mere byproduct of brain chemistry, but a central feature of the design, the point at which the universe becomes aware of itself. This frame offers a powerful sense of meaning and belonging. It places us within a story that has a purpose and a direction. The frame of emergence offers a different but no less awe-inspiring perspective. It looks at the same complexity and sees it as the spontaneous bottom-up result of simple rules playing out over immense scales of time and space. From this viewpoint, life is not designed, it arises. Consciousness is not bestowed, it emerges from the growing complexity of neural networks. The fine-tuning of our planet for life is a result of survivorship bias. We exist on a planet that happens to have the right conditions because it is impossible for us to have evolved on one that did not. There may be billions of sterile worlds for every living one. This frame offers a powerful sense of the universe's creative potential, its capacity to generate astonishing complexity out of simple beginnings without any need for a guiding hand. What both frames share when approached with humility is a profound sense of wonder. Whether you see the world as a meticulously crafted artifact or as a magnificent self-organizing phenomenon, the result is a deep appreciation for its beauty and complexity. You can arrive at the same feeling of awe by two very different paths. And our model of the Ice Age can be viewed through either lens without changing the facts on the ground. The resilience, the artistry, the deep knowledge, it is all there, waiting to be interpreted, a testament to something remarkable, whatever you choose to call it. Let's bring this journey home, right back to you, here, now. The ultimate implication of everything we have explored tonight is a simple one. You are in the loop. You are not a detached observer of these vast, ancient systems. You are a living, breathing participant. This is not a metaphor. It is a literal truth. The calcium in your bones and the iron in your blood were forged in the hearts of long-dead stars. The water that makes up most of your body has been cycling through the Earth's oceans, rivers, and atmosphere for billions of years. The oxygen you are breathing in this very moment is a gift from countless generations of photosynthetic life. Your DNA contains a library of information, an archive of the survival challenges faced and overcome by every ancestor you have ever had, stretching back to the very beginnings of life on this planet. You are a walking, talking piece of the Earth's history. This sense of personal belonging can be felt in the most ordinary moments. When you feel the warmth of the sun on your skin, you are feeling the direct output of the fusion reactor that powers our entire solar system. When you drink a glass of water, you are taking in the same molecule that carved the Grand Canyon and fell as rain on the Mammoth Steppe. Your body is not a sealed container, it is a porous, permeable system, constantly exchanging matter and energy with the world around it. This is the essence of embodied agency. Recognizing that you are part of the system, not separate from it, changes your relationship to it. It fosters a sense of responsibility that is born not of guilt, but of connection. The choices you make, however small they may seem, ripple out into the interconnected web. This is not a burden. It is an invitation. An invitation to see the world not as a collection of objects, but as a network of relationships, and to recognize your own undeniable place within that network. You belong here. You are a momentary but beautiful expression of a 4-billion-year-old story. So where have we been tonight? Let's retrace our steps in a brief final recap. We began with a single, elegant question. How could you, a modern human, have lived in the Ice Age? We decided to approach this not as a test of strength, but as a lens for inquiry and exploration, guided by curiosity rather than a search for certainty. We grounded ourselves in the present moment, in the sensory reality of the room around us, establishing a baseline from which to journey into the deep past. From there, we explored multiple tracks of evidence. We looked at the human scale, seeing in a single stone tool a world of skill, artistry, and social complexity. We zoomed out to ecological systems, understanding the dance of predator and prey, and the conversations between biomes and the atmosphere, not as conflict but as self-regulating feedback loops. We expanded our view to the planetary scale, appreciating how the gravitational embrace of the Moon provides the long-term stability necessary for life. And we dove into deep time, learning to read the archives of ice and sediment that record the Earth's ancient rhythms. We confronted the objections, steel-manning the case for a brutal and short existence, and acknowledged the profound limits of our knowledge. We then took a turn, reframing the simple binaries of survive, die, and human nature into more fluid and realistic spectra. This allowed us to build a synthesized model of Ice Age life, one that sees our ancestors as highly skilled and resilient participants nested within a complex, multi-layered, and often volatile world. Their success, we concluded, was a story of social and cultural robustness in the face of immense individual risk. We translated this model into a sense of felt meaning, humility, awe, and a deep sense of belonging. And now, after this long walk, we arrive back at the beginning with our question. How could you survive in the Ice Age? Perhaps the answer is not about what you would do, but about what you would need to be observant, adaptable, cooperative, and deeply, profoundly connected to the world around you. Perhaps the answer is that the tools for survival are not just in our hands, but in our relationships with each other and with the planet that is our only home. As our time together comes to a close, I just want to extend a quiet thank you. Thank you for your time, for your attention, for bringing your own curiosity to this shared space. In a world of speed and distraction, to set aside an hour or so to slowly and gently consider a single idea is a rare thing. It's a small act of reclamation, of choosing a different pace. Whether you are listening to this as you drift off to sleep or during a quiet moment in your day, know that your presence is what makes this exploration possible. This is not a lecture. It is a conversation, and you are an essential part of it. If you have found this journey restful or thought-provoking, you are welcome to join this community of quiet curiosity by subscribing if you haven't already. But there is no urgency, no imperative. The most important thing is that you found your way here for this moment. Thank you for being here. May the rest of your night or your day be peaceful. Let's allow the threads of our conversation to gently loosen. There is no need to hold on to all the details, the facts, the models. Let them recede like a landscape fading into twilight. The goal was never to memorize information, but to cultivate a certain feeling, a certain quality of attention, a sense of wonder, a sense of connection, a sense of the immense and beautiful depth of time. As you settle back into the quiet of your own space, just rest in that feeling for a little while. There is nothing left to figure out, no conclusion to be reached. The journey has been the destination. The questions are more important than the answers, because it is the questions that keep our curiosity alive. It is the questions that keep us humble. The world of the Ice Age is gone. Its sounds are silenced. Its light has faded. All that remains are whispers, fragments, echoes in stone and ice, and in our own DNA. But by listening to those whispers, we can perhaps hear something profound about ourselves. We can feel the long, unbroken thread of continuity that connects our world to theirs. So let the stillness settle. Let the curiosity remain, not as a restless searching, but as a quiet, open-ended wonder. A peace that comes from knowing you are part of a story so much larger than yourself. And so we end where we began, in this room, in this moment. Feel the air again, the same air we first noticed, but perhaps it feels different now. It is the same substance that filled the lungs of mammoths. It is the same atmospheric ocean that carried the dust of glaciers across continents. The materials that surround you, the wood in the floor, the metals in the wiring, the silica in the glass of the window, all are elements forged in the cosmos, drawn from the crust of this planet. They have their own deep histories. Look inward to the darkness behind your closed eyes. In that quiet, internal space, you carry the legacy of 100 billion lives that came before you, each one a successful solution to the problem of staying alive for one more day. The resilience we spoke of is not an abstract concept from the past. It is in you. It is the quiet, steady rhythm of your heart. It is the unconscious, elegant process of your breath. The world of ice feels impossibly distant, but the line that connects you to it is direct and unbroken. You are the latest expression of its story, Rest in that knowledge, rest in the quiet continuity of it all. Good night.